Thank you. So welcome everyone. Today I will show you how to migrate your Java 8 or 11 service to another very great JVM language, at least in my perspective. Most of the Java services are still written in Java 8. More and more services are migrated to Java 11. But I think this is a really great alternative to implement in your backend services. Kotlin is known for in the Android world, but I think it should get some more traction on the backend side. So we'll show that to you today. So my story with Kotlin, it started a few years ago, where in my team we were really happy about Java 8 and its functional programming implementations, at least with Spring. So the code base was filled with such change of collection manipulation, where we had a lot of filter statement and map reducing. And actually this example would be a very short example of what we had in the code base. And after a while, this became unmaintainable because, well, we had too long chains of collection manipulation. And well, that was a problem, which we should have refactored it by then. But we wanted to achieve something a bit bigger than refactoring, extracting functions and stuff. We wanted to go to some code looking like this, where actually this filter statements, filtering out the board games, suitable for a minimal number of 2 players, would be expressed in a function called more than 2 players. And the next filtering statement, instead of seeing filtering again, I would have like to have a method called older than 10 to play, and the same with the map reduce statement, just confine it in one function. And actually back then we found that into Kotlin. It was Kotlin 1.2, I think, back then, and it had already the extension functions, and we could actually refactor our code base using those extension functions. We didn't do that right away because this is a pretty advanced feature of the language. We started with all migration plan to achieve to having a code base which was more readable and more maintainable than we had in Java 8. So this is a bit about my story with Kotlin. So who am I? As Paulien just mentioned, I'm Paulien van Alst. I'm working for OpenValue. We are a small company helping out companies to innovate their software engineering. I'm also hosting a podcast about software engineering called Barcoding. You can find us on barcoding.dev, on Twitter, Spotify, Apple Podcasts, Google Podcasts. In my free time, I like to play board games. So this is the theme of the application that we're going to migrate today. So it explains a bit. And you can find me on Twitter as well if you want to. And since a month, I'm also a Google developer expert in Kotlin, focusing on Kotlin backends. So a small and quick recap about the new Java versions since Java 8. Java is really trying to innovate and listening to the community and bring some awesome features in, like switch statements, type inference, the G shell. You can finally program Java in your terminal if you want to try something out. Convenient methods for collections are added, and the release cadence has been increased. So every 6 months there's a new release, but the LTS versions are still every now and then, which is a great improvement, this release anyway, so it's really cool. And they added, I think since Java 14, records which are confined classes for your domain object. So this is really cool in Java, but so why even look at Kotlin? Well, because I think Kotlin is even better and improving itself in another way, which can be really interesting as well. So some reasons to switch to Kotlin. Well, it has regular updates. They're using the semantic versioning, like a lot of libraries and frameworks out there. So there are patch releases, there are minor updates, not yet major updates, but still. So that's, I think, something that's very valuable. The interoperability with the Java ecosystem is enormous. They rely highly on it, which makes it easy to integrate Kotlin into your Java service. If you're working on a mobile-first application, the multi-platform release of Kotlin is a great advantage as well, because you can use the code base for your iOS code, your Android code, and your web code in, you can just have that in one repository. So it's just one single code base. So that can be a good reason to switch to Kotlin as well. But where for the backend functionality of Kotlin, so then readability can be a great argument. Kotlin language features are really designed to have more readable and more business-oriented code. So it's a really big advantage. Less boilerplate. And when you're saying readability, you're saying, more maintenance that's easier to do. Less boilerplate, again, less maintenance. And safe programming. What you should know is that having a null pointer exception in Kotlin is very hard. You should really do your best to trigger a null pointer exception. So safe programming is really easy in Kotlin as well. Another thing is that Spring is used a lot in the Java community for backend services, and Spring is really hopping on the train of Kotlin. For the next Spring Boot release 2.4.0, there will be even DSLs, domain-specific languages, for at least the web side of your application, so for your endpoints. Webflux is already proposing that. Coroutines, if you want to do multi-threading programming in Kotlin, then coroutines are the way to go. And here on this part, again, this is a part where Kotlin distinguishes itself from Java. Supporting the Java ecosystem, a lot of Java libraries are moving towards supporting Kotlin as well, and the number of those libraries and frameworks are really growing. And the Kotlin ecosystem is becoming bigger and bigger as well. With Kotlin ecosystem, I mean frameworks and libraries that are designed for Kotlin by Kotlin programmers. So no influence of the Java ecosystem there. One example is Ktor, for example, which is a backend framework, kind of equivalent to Spring, but more focused on the multi-threading programming. Spring Webflux is already supporting Kotlin in a great way. And Micronaut and Quarkus, I forgot the logo there, but Quarkus as well are supporting Kotlin. So if you're looking to those kind of frameworks, Kotlin can be a way to go as well. So what to keep in mind? It's a downside as well, the interoperability with the Java ecosystem. Ever since I'm learning Kotlin, I'm also learning about Java and its frameworks and its ecosystem, as Kotlin has some features which make interoperability with the Java ecosystem a bit awkward, I would say, because while you still have nullable types in your Java libraries, Java libraries highly depend on reflection and on proxying classes, where Kotlin prefers final classes, immutability, and non-nullable types. I will show that during the code demo. The idioms of Kotlin are something you really should understand before starting writing your code base of Kotlin, because otherwise you will write Java equivalent code and not proper Kotlin code. It's not a magic problem solver. At my team, we thought it would solve all our problems. Of course not. If you have a messy code base, it will remain messy if you write it into Kotlin, of course, but it will definitely help you to refactor your code. At least that's my experience. So just to make a statement here, Kotlin is not just a better Java version. It's not a synthetic sugar around Java. It's really also promoting new cool features in the language, which are technically very good. So let's start to have a look at our application. The application that we're going to migrate today is a service proposing two endpoints. One of them will enable us to rate games, board games. So, for instance, assign 8 out of 10 to the game Dominion. And another endpoint where we can retrieve all the games that were rated higher than an 8, for instance. And then we will retrieve some popular board games such as Dominion and Ticket to Ride. I went a bit fast on there on my animation, so let me get clicked through it. So here you have another overview of the service. The technical details, it's a Spring Boot 2 service. Yeah, so nothing special there. It's pretty standard in the Java world. An in-memory database, because that's a bit easier for the demo. And it's tested through unit test and integration test. I'm also using Maven, and I'm doing that on purpose because a lot of examples in the Kotlin world are done with Gradle. So I wanted to show you an alternative on that part. The migration plan that I want to show you. What we did back then was starting with setting up the dependencies that you need to work with Kotlin. That's already one big part to see if you don't have conflicts on your dependencies. Then the second step that I would like to propose to you would be to migrate your plain Java objects to describe your domain. Yeah, your functional domain, and you will already gain a lot by doing this step actually, and I will show you later on why. The third step would be to rewrite your unit test. There you can already learn a bit more about Kotlin and get yourself a bit more familiar to the language. Fourth step would be to attack the core logics. If your tests are great, you can refactor your core logic, and you would already have learned a lot about Kotlin to do that properly. And last but not least, of course, your Spring configuration. Now, let's start the code. So what I'm going to do is stop sharing this application and go back to my Zoom call and share my IntelliJ view. So this is the application. Let me put on the presentation mode so you can see it. The application that we're going to refactor here is an application holding 2 packages, one for the API description describing a board game, and one service package which holds the endpoints, the service, and repositories that you need to access your database. It has some tests, actually 2 tests, not a proper test permit, but all right, a unit test and an integration test. The integration test is just checking if the endpoints are still working and returning the values properly. It will also fire up the application. So if I am going to do a Maven verify, this is my alias for Maven verify. I hope it will work now. Yes, of course. Here you will see that it's compiling proper Java code, and nothing very unusual there. It will run the test as well. A lot of Spring logging, which is good because it means it's booting my application in a test. And at the end, you will see that the 4 tests have been run during this cycle of Maven. So here you see it, test run 4. So great, we're good to go. Our application is fine. We can now start with the first step, which would be to set up the dependencies. And I've already prepared that for you because that's a bit easier. And it didn't, yeah, there we are. So to set up the dependencies, I will scroll back to my pom.xml. What you see here is that I specified the Kotlin version. Bit. What you also need to add then, of course, in your POM is some libraries to have at least access to the code, a library for the unit test, and then if I scroll back to my build cycle, I am here using the Kotlin Maven plugin, and then some complicated execution configuration. You can find it on the Kotlin website. That is needed because I'm here combining Java code and Kotlin code into one repository. So I need to tell the compiler, you can find all my source code over there, and it's fine. You can compile my Java code and later on my Kotlin code, and they are able to talk with each other as well. So once I've done that, it will again, I will verify if my application is still starting. I would advise to do this in a single step, a single commit actually. The Spring Boot parent that I'm using here has a Kotlin bomb, so it's good to check if no versions conflicts are happening over there. What you can see here is that Spring is started. In the logging here, I see that it's also connecting to the database. So as you see, my 4 tests are successful, my build is successful, so no versions conflicts here. My second step in my migration plan was to migrate my plain Java objects. So let's go to the API package. I have here my home and my domain description. My board game class is the most important one in my repository, of course, because that's my main entity, which is described over here. And I will start to refactor that to Kotlin actually. So what I will do is to make a file called board game, just a Kotlin file. That's okay. And I'm a lazy programmer, right? So I will just do some copy pasting. Why not? And here, IntelliJ is really awesome. It will say, okay, you're lazy, you're doing copy pasting. I will even do the work for you. So of course I will say yes, as I'm still lazy. And it's compiling, it's now rewriting my code to Kotlin. What do I see here? I see here Java Kotlin code, which is Java equivalent. It doesn't respect any idioms of Kotlin yet. So I need to do some refactoring. I'm not done. IntelliJ didn't do all the work. As many Java code bases, I'm relying on the third-party library Lombok to avoid a lot of boilerplate code in my code base. I'm going to remove that because I don't need it anymore as I'm using Kotlin. I can declare here a data class, which is almost the same as records in Java 14. The thing with data classes is that you can declare your entity with its fields, and you will then have a copy method, a toString method, a hashcode method, and an equals method. The copy method is there on purpose. It's a big difference with Java, as Kotlin embraces immutability. So it will enable you to have immutable objects there. Now it's not compiling now. Why? Because a data class expects a direct declaration of the constructor. So I need to replace the curly brackets with rounded brackets to starting declare my constructor. So now it's all messed up, but that's fine. Let's fix this. I don't need private here because I don't need to get this. I'm fine with it. They can access my members directly. The other thing is that Java really likes nullable or only accepts nullable types. So what it did here is that it declares nullable types instantiation, and the fields are instantiated with nil. And I'm removing that as well because I want to have that nil safety which Kotlin has to offer. Now let's remove the Java entity non-safely. What you will see now is that I removed the Java entity and replaced it by a Kotlin entity. And let's now check if my code base is not only compiling, but also still my application is still running, right? Because I have some great integration tests that will spin up my application. And if this is working, this means that also my API didn't broke. So this is something that's very valuable. What you can see now in the logging of Maven is that the Kotlin Maven compile is now doing its job. There's some warnings that's for now for this presentation, all right. And you can see that my Spring application is started again. And hopefully my tests are green. Of course, my 4 tests are run. So the result here is that all my code is Java except with one entity, which is Kotlin, and it's already working. So that's great. Let's just stash this and go forward to the end result. Oh, something wrong. Let's go to the branch which has all the API migrated to Kotlin. This is the final result of my API migrated to Kotlin. Another great feature in Kotlin is that I can group data classes in one file. That will work fine. In Java, that's not possible. This enables me to really gather the objects that belong together. Another great feature here is default values in the constructor. So a lot of board games have a maximum age from 99. Never understood why. If you don't want to implement that in your business logic, you can use the constructor holding only one parameter. If you want to override it, you can use the constructor with 2 parameters, but you only have to declare one constructor in such a way. So that is it. So going from a lot of files declaring Java objects, I only have one file having Kotlin objects. For the sake of time, I won't run a Maven verify here, except that this is working. We will continue with this code in the second step. The third step, I'm sorry. The third step would be to implement my unit test. I will just quick show you the unit test as it is. This is the unit test in Java. It's using Mockito to mock my dependencies of my bean, and it will just use Mockito with the expectations of the mocked calls, and then here the call that is tested and some assertions. So let's have a look at how it looks like when I'm writing this down in Kotlin, because this is interesting here. Kotlin doesn't really like, how do you say it, proxying and non-final stuff. So I can still use Mockito, as I did here. This is the Kotlin equivalent code. It's a unit test where I'm using Mockito to mock the classes, but it's using here Java classes. So I'm still living in the Java world. But already I have some huge improvement. I'm using backticks to declare my functions. Really nice language feature that should only be used in test code, actually. So it makes it more readable to read scenarios. I need to use here backticks as well, because when is a reserved keyword in Kotlin. But then to make it a bit more readable, I used extension functions to declare the return values of the mocking call. Another feature that I use here from Kotlin is to use the structuring of the return value. I only want to assert on the rating value, so I can just destructure it like this. Another way to do this is to go more into the Kotlin world and to use another framework, which is called mock, but then with 2Ks, a bit confusing. Here I don't need to cast my mock to a Java mock. I can just stay in the Kotlin world, still using the backticks to declare the function, but now I'm using the DSL that mock is offering. So every call to the repository should return with this value, should return this optional value, and such. So let's see if this still is running. Now I've added 2 tests because I'm showing you both versions of the Kotlin code. At the end, you will see that 6 tests have been run, which means that also my dependencies are set up correctly, as it is including Java code, Java test code, and Kotlin test code. So now it's already running the integration test. So yeah, we can assume that the unit tests have been run as well. Let's just, I like to deliver some proof. So in a few minutes it will, oh no, it's running after it. That's fine as well. So as you can see here, the 6 tests have been run. Yeah, so Java and Kotlin tests still running together in the build. That's great. My hybrid solution is working. So we're now arrived on the fourth step, would be to implement the business logic. And in the sake of time, I will show you the end result already. Before migrating my business logic in my Spring Spring components, I will show you the dependencies that I need to do to make Spring work with Kotlin in a proper way. Let me go to the dependency section of my POM file. I need to include the Kotlin reflect dependency because Kotlin is not really comfortable with reflection. So you need a dependency to make that work. So this is the part where my presentation has said sometimes the interoperability is a bit awkward. You need to add some dependencies to make it all work. Another thing is that I'm using here a Kotlin logging framework, which is a wrapper around log4j to make the string interpolation work correctly in a performance point of view. Now, let me scroll back. I hope I'm not scrolling too fast for you. Let's go to the build plugins. There we are. I remember this very big execution configuration here. Well, here it is the dependencies of my Kotlin Maven plugin. I had to add some configuration there. First of all, I'm accessing the database with my Kotlin code, with Spring Data, which means that I need a compiler plugin for JPA. This one and another one is the dependency of the Kotlin Maven no-arc library. And the reason for that is that Spring Data is instantiating my Java objects as empty objects and then injecting the values from the database into the fields. So that means that a no-arc constructor is needed for the database entities. However, data classes in Kotlin only have full arc constructors. So in that regard, you need a dependency to do that for you, to declare no-arc constructors and a compiler plugin to be able to inject those values into your entities. Again, a bit awkward. Now let's go to the code that has been migrated already. This is the surface that I've migrated from Java to Kotlin, and let's see how it looks like. It's a Spring Bean, so it has the surface annotation, and then I need to do something special, is to add the open keyword to the class. Why do I need to do that? Well, classes are final in Kotlin. Spring wants to proxy the classes, so final classes are not really working there. So you need to declare them open. There is a Maven plugin that will do that for you. I'm not really a fan of that. I want to have an explicit code base where also my teammates understand what is happening there. So I'm using the open keyword there. I'm using my Kotlin logger. Then the first method is declared here. I start with the keyword fun, the name of the method, the input parameters, and the type. The return type is declared over here. I start with declaring here a rate entity. That's fine. I do that with the val keyword. There is also a var keyword in Kotlin like this. With var, you indicate that it's a variable which can be mutated. With val, I indicate it's an immutable field. Here I'm using string interpolation. That's another awesome feature in Kotlin, I think, is that finally you can be safe on where the values are injected into your string, especially for logging. That's very valuable. This logging framework will enable you to do that string interpolation only when the logging level is correct. And then let's go to the last line of code. Here my entity returned by the repository, which is an optional, is directly mapped towards another entity which is built up by this function. and I don't need to use the syntax like this, which is a bit longer. I can just remove the parameter declaration and use the keyword it, which is referring to that iterated entity. You can do this the same way for instance, in the second method, where I'm returning a collection and where I'm mapping all the elements of the collections to another type of entities. I can again use the it keyword. And the biggest difference with Java is that I don't need to collect this back to a list or a map or whatever collection I want to. It will just return a collection right away. One thing is that this is eager. There is a subtle difference between eager and lazy evaluation. To have a lazy evaluation, you can use a sequence. So that's a big difference with Java. You need to be aware of that. Now it will return a sequence instead of a list. So something to be conscious there. Let me just, I see that I have some changes left, so I'm going to stash it. What you now can see if I go to my classes here is that I have migrated my service with all my core logic to Kotlin. My endpoint here has also been moved. It's also a REST controller, an upper class, using the proper annotations of Spring. That's fine. I'm here using still Spring 2.3.5. With Spring Boot 2.4.0, I would be able to use here the DSL of Spring and Spring Web. But yeah, it's not a released version yet, so I didn't feel comfortable to do that. So it still looks a bit like Java, actually. The only part that is still Java-like is the repositories here and the application. So let's see if that's if now it's running, having just Java repositories and but the rest of the code base being Kotlin. You can see here that the Maven plugin is applying the JPA plugin. And I hope it will turn out fine. Yeah, it's the compilation worked. Now let's see if my endpoints haven't changed, because my integration test, yeah, well, I still want my endpoints to work, right? I don't want my clients to have noticed that I'm doing this all. So at least my integration test worked, and my unit test worked here as well. So my validation is going well here. Now, last but not least, is that I need to migrate my Spring configuration. The last part is that I want to rewrite my Spring Boot application. Well, it's still an open class, but with no declaration into the class. That's all right in Kotlin. That's fully acceptable. And my booting function is lying in the same file of the application declaration, but it's a separate method on file level and not in the scope of the class. And this is how then the Spring Data repositories look like. It's annotated with repository. It's just an interface inheriting from the CRUD repository. Instead of using the keyword inherits, I can just use a semicolon, and then it will work fine. So yeah, let's have a look. Is it still working? The point that I want to prove here is whether the booting of the application still works, because this is the part that I have migrated here. While it's running, I can show you the entities classes that look like this in Kotlin. I'm using their data class again because I'm alright with that, and then in the constructor I will just declare the fields. The ID is a nullable type indicated by a question mark, and that's it actually. The build is running now. Let's see if the application is starting properly. Well, it looks like it's still a lot of Spring logging. I guess we're there yet. Yes. So my integration test worked, which is something I wanted to prove to you. So I will stop sharing now because we migrated the whole application from Java to Kotlin. And I will come back to my presentation. So we did the coding. So what did we do? In recap, we set up the dependencies. We migrated the Java objects. We rewrote the unit test. We rewrote the core logic of the application. The configuration was rewritten as well. So that was a successful migration. So welcome on board, everyone. You just rewrote your application from Java to Kotlin. That's it. So if there are any questions, please shout.